Here I want to talk about probability tree diagrams. Before I make a tree diagram, just want to quickly explain to you what I'm going to do here. Let's suppose I play football Mondays and Tuesdays. Only Mondays and Tuesdays. There's two possibilities. I could win on a Monday and win on a Tuesday during that week. Okay, so that's a good week for me. I'm not going for a draw, by the way. It just makes the diagram more complicated for now. So win-win. Right, what else could happen? I could win on Monday and end up losing on a Tuesday. What else? Could be that I lose on a Monday, win Tuesday, and then worst week, lose. Those are the possibilities. Any one of those four possibilities could happen in any particular week. How am I going to represent that on a tree diagram? So watch. I'm about to make a tree diagram. On a Monday, two possible timelines. It's going to be win or lose, all right? Just bear with me. Let me just finish this. I'm just duplicating the win-lose branch. There you go. So on a Monday, this represents Monday, this represents Tuesday. What could happen is I could win, or win, lose. What else can happen? Lose, win. The worst week ever, lose. Four different timelines. That's a tree diagram representing this. Sample space diagram. Right, sample space diagram, tree diagram. Now let's put some numbers in there. Let's start on a Monday, probability of me winning. Right, I'm not going to use words like likely, unlikely, 50-50. I'm just going to put some numbers in there. On a Monday's not a good day for me. Right? So let's say on a Monday, probability of me winning is just 2 in, let's make this up, right? 2 in 11, 2 out of 11, 2 11ths. I've just made these numbers up, but I made the numerator small, so it looks like it's unlikely, very unlikely, just 2 in 11 chance. That's for a win on a Monday. But for a lose, it has to be what? It's going to be something out of 11. It's going to be 9. Why? Because 9 add 2 makes 11. In other words, 2 11ths add 9 11ths make 1 whole. All right? We're talking about fractions here. 2 11ths plus 9 11ths make 1 whole, and each branch has to add up to 1 whole. On a Tuesday, slightly different, right? Better day. On a Tuesday, probably to move winning. Just going to make this up. 7 ninths. So that means losing is going to be 2 ninths. Why? Because 7 plus 2 makes 9. 7 ninths plus 2 ninths make 1 whole. And because this is Tuesday, I'm going to copy that over here as well. I'm going to copy this branch over here. Right, where I got these numbers from, I've made these numbers up. But at least the maths is right. Look, 2 11ths plus 9 11ths make 1 whole. 7 ninths plus 2 ninths make 1 whole. 1 whole. Each branch has to be 1 whole. So I'm going to do some maths behind this. Let's suppose I want to work out the probability, P for probability of me winning and winning the second time round. Winning and winning. So I'm looking at this and this branch here. That's 2 11ths. And because I'm going across the branch, I need to times 7 ninths. Multiplying fractions is very easy. Numerator times numerator, denominator times denominator. Be careful now, that doesn't work for division, but we're not going to do division here. Division is keep change for your information. Right, 2 times 7 is 14, 11 times 9, 99. So probability of winning and then winning again, Monday and Tuesday, is only 14 out of 99, 14 99ths. Unlikely. Probability of me, let's say, losing and then winning. Losing first and then winning. Losing on a Monday, winning on a Tuesday. Monday, Tuesday. So we're looking at losing, winning. This branch over here, that's 9 11ths multiplied by 7 ninths. 9 times 7, 63. 11 times 9, 99. And then if you can simplify then. Right there, sorry about that. You can see this now. So just if you missed that, 9 times 7, 63, 11 times 9, 99. 63 out of 99. You can simplify, divide by 3, divide by 3. Gives you 21 over 33. You can divide by 3, divide by 3 again. I should have just divided by 9. Would have been quicker. So 63 divided by 9 gives you 7. 99 divided by 9 gives you 11. That's slightly more than 50-50. Right, this one here. Probably me winning one game and losing one game. Now it does not say winning on a Monday and then losing on a Tuesday. No. Winning one game. Could be Monday, Tuesday. Monday, Tuesday. Losing one game. Could be Monday or Tuesday. Probably make, okay, we look at the different possibilities. To win one game and lose one game. For that to happen, it could be win, lose, or lose, win. So that's what I'm asking. Probably to winning and then losing, or losing the first game and then winning the second game. Right? So there's two different timelines that satisfy this question. So let's break this down. Win and lose. Probably to me, winning and then losing. Winning and then losing. That one there. That's 2 11ths multiplied by 2 9ths. And this one here. Losing, winning. Lose, win. And then win. When it says or, you don't times, you add. That's the significance of or, is you adding. So let's work this out. That's going to be 99. 3 over 99. Right, if the denominators are the same, copy the denominator. 63 add 4, 67. The answer to that question, winning one game and losing another game, 67, 99, so right? Slightly more than 50-50. Right, just out of interest, if I wanted to make, well, same 2 days, but this time you can win, lose or draw. You can imagine how much complicated this diagram would look. You could have win, lose, draw. That's for the Monday. You can see what I'm doing here. Win, lose, sorry, that's win, lose, draw. Win, lose, draw, win, lose, draw, win, lose. You can see a lot more numbers would go there, but one thing you'd have is each branch would add up to one whole, one whole. And then you can imagine if I had Monday, Tuesday, Wednesday as well, there'll be 3 coming out of there, 3 out of there, 3 out of each one of those. So you get a lot more complicated. Right, remember, tree diagrams doesn't have to be win and lose, win, lose, draw. It could be other things, like coming in late into class and not late. There's only 2 possibilities. You could either be late or not late. So if you're not late, so if you're late, you can get a detention or no detention if you're lucky. Right? Coming in not late, I mean, we shouldn't really need this. Okay, so not coming in late, just join the class. Okay, nothing to worry about detentions. So this is the tree diagram. Let's put a figure to this. Let's say probability of coming in late for a person 1/7. So what's not late going to be? It's going to be 6/7 because 1/7 plus 6/7 makes 1 whole. 1 plus 6 makes 7. Same as the denominator. Right, let's go along here. If somebody does come in late, somebody does come in late, it's very likely that they're going to get detention. We'll call that 9/10. No detention. That means, because that's 9/10, we've chosen that's 9/10, that this one will have to be 1/10 because that makes 1 whole. Then I can ask the question, what is the probability of somebody coming in late and then getting no detention? Let's have a look. Late, no detention. That's 1/7. Replace and with times, not adding, and then no detention. That's 1/10. 1 times 1 is 1, 7 times 10 is 70. Right, that particular type of person, normally very punctual, of getting a detention, obviously for coming in late, is 1 in 70. 1/70 is very unlikely. But if this is a different kind of person, normally comes late, 6 in 7 chance, that's going to change now. So the maths become different now. Late, 6, 7, and then getting the detention. 6 times 9, 54, 70. Right, that particular kind of person, who's normally very late, normally comes late to class, that kind of person normally always gets detention.